Okay, good morning, everyone. This used to be smaller last year, but try to get used to it. Yeah, welcome to the course GeoPython. My name is Kamya Hassanzadeh. I'm a lecturer in geoinformatics in Department of Geoscience and Geography from the geography side. Yeah, and this is our first lecture. Usually this lecture structure is a little bit different because we have a bit of slides at the beginning, but usually we never have slides actually. So from the next week, it's just hands-on coding. But today we have a bit of introduction into the course, of course, and also some basic concepts related to programming and computer, because I know that many of you are very new to programming, and that's perfectly okay. Yeah, so this is the structure of what we are going to do today. We will have an introduction to some of the practicalities of the course. We will learn about the elements of computer and computer program, and an introduction to our course, computing environment. There are a few pieces that might seem a bit scary or confusing at the beginning, but each piece serves a purpose, and as you progress during this course, you will see that it's not that scary. And then a taste of Python. That's the second part of the lecture today, where we start coding already. So we will have a break in between. Okay, so I start with a bit of introduction. I introduced myself briefly already. I'm from the geography side. I have a background in geoinformatics from Aalto University. In my master's and in my PhD, I studied urban-related topics. I did my PhD in land use transportation engineering. So I have a background in geoinformatics, and then I've worked on multidisciplinary topics. Usually I teach this course together with David Whip from the geology side. And many of you who come from the geology side probably know him from other courses. But this year he's away on a sabbatical leave, so he's not even in Finland. So I will be teaching this course alone. Of course, I'm not alone. I have help from the course assistants. We have 3 course assistants this year. We have Emilia, Inka, and Evi. Inka is from the geology side. The other 2 are geographers, but it doesn't really make a difference. So if you have a question about anything in this course, so you can approach any of the assistants. Yeah, so I will be your lecturer for this course. So even if you're coming from geology and you have administrative questions, I will be your contact person this year. So you probably noticed I sent you an email on Friday. So the course is an open course, actually. It's the first part of a 2-part course, GeoPython or AutoGIS. Those of you who come from the geology side, well, you have different codes for the course, and you might know the course by the name GeoPython most, and those who are coming from geography, you might know the course as Automating GIS-processes, but they're the same thing. So this is a 2-part course. In the first part, this is where we are, GeoPython or Automating GIS-processes. We have an introduction into Python programming, so we don't expect you to know any programming. Of course, if you do, some of the things will be a lot easier for you. You might be even bored at the beginning, but things get a bit more advanced in coming weeks. So hopefully there will be something new for everyone sitting here. In the second part, which mostly geography students take, we do GIS. So in the first part, we don't really do GIS. We learn what we need in order to do GIS in the second period. So there is really not much GIS content in this first part of the course in this period. And these are open courses. I'm going to show you later on the course's website. These are open courses, meaning that we know that there are people taking the course or even teaching this course in other parts of the world. So the contents are available to everyone, but of course the grading and the support we provide you is only for students who are officially enrolled in this course. That's why, for example, I sent some of the links only in the email. One thing I would like to mention before I go further on is that I'm actually recording this lecture. You're not in the camera, but just the stage. As I said, it's an open course, and there are people also following the course remotely. So the idea is that probably the day after the lecture, the lecture recording will be uploaded to the course's website. So if you cannot make it to the session, you can follow the lecture online as well. So this is our schedule for this period. We will be meeting every Monday from 9 to 12. We try to finish it at 11:45, but but hopefully no later than 12. And we have optional work sessions, so these are optional, meaning that you don't have to go there. Even the lectures are not mandatory. I'm not going to check the attendance. But of course, you will see we have really hands-on lectures, so you will be really doing things. So it would be best for you to be here and participate in the lectures. But I'm not going to check the attendance. The work sessions are also optional. They happen on Thursday and Friday. Again, depending on which version of the course you're enrolled to, like geography or geology version, you might be enrolled to different sessions, but it doesn't matter. Whenever you want to go, if you have questions. So the idea is that you go there, you do your own thing. These are computer classrooms in physical. You do your own thing, but the assistants are available. So if you're stuck, if you have a question, they will be there to help you. But regardless of which session you are enrolled to in SISU, you can go to either of them, so it doesn't make a difference. So as I already said, the first part of the course, which is this one, GeoPython, we will have an introduction to programming. After a few weeks, we will start data analysis, so we learn some libraries in Python that allow you to perform proper data analysis using programming. And toward the end of this period, we will learn how to make different kinds of visualizations, for example, charts. And in the second part, if you're interested, we will continue with the spatial data and doing GIS and working with maps and spatial analysis. And each of these courses are 5 credits. So I introduced myself briefly. Now it's your turn. Since I'm recording and the class is big, I cannot ask you to introduce yourself, so let's just open this poll. It's a Presemo poll, and answer a couple of questions about yourself so we know who we have here. Okay, so now you should be able to see the first question. Okay, so at least from those of you who are present now in the classroom, about half or about 11 are from the geology side, 10 from the geography side, and we have students, of course, from Aalto University. We also have students from Turku, maybe not right now here, but there are students taking this course from Turku as well. Under the geology course, we also have the Open University, so we might have other students who are not from geology, but they are enrolled to the geology version of this course. So we have a very diverse group of students coming from different disciplines and even different institutions. Now let's move on to the second question. The second question is, how much programming experience do you have already? Okay, so again, quite a bit of diversity in terms of your experience and skills in programming. Many of you, the majority of you, do not have any experience with programming. That's perfectly fine. We are going to start from the very basics, so that's not a problem. Some of you have a bit of experience. You might get bored of the first couple of lectures a bit, but later on, when we get to other topics like data analysis and visualization, those are probably new to you. But yeah, there is something for everyone here. Let's move on to the third question. So those of you who have done a bit of programming before, which programming language have you worked with? Okay, so majority of you seem to have some experience with Python, some with R, Java, JavaScript, C family languages, MATLAB, and so on. So it's nice. Many of you have a bit of experience, at least with Python already, and that's the programming language that we are going to use in this course, and the second part if you continue with that one as well. Let's move on to the next question. And these questions will help us. I have already sent you a link to a questionnaire on Friday, but these questions help us like adjust the contents of the course a bit. So what are your expectations for this course? What type of things are you interested in or hoping to learn this period? Okay, so many of you want to learn, of course, coding and programming, data analysis with programming, GIS-specific coding, confidence, I assume, in programming, good Python skills for GIS. Yeah, so most of the things I see here are pretty much covered in this course, so you're in the right place. You will learn programming. By the end of already first period, you will be rather confident in using Python language, especially for data analysis and basic visualization. And for those of you who continue to the second period, you will build confidence in using Python also for GIS and special data analysis. Good practices for version control. Like this is something we are going to talk about a lot starting from next week. We will work with version control, so some of you might be familiar with GitHub and Git. So that is also something that you will learn along the way. And good coding practices, this is also something we talk about almost every week. So we have a part toward the end of each lecture, good coding practices. So not only we learn how to program, but also we learn how to write our Python codes properly. Enough Python to be able to use QGIS, ArcGIS plugins. Of course, we learned the basics of Python already this period, and in the second period, we will get more deeply into GIS topics. I want to write Python to automate repetitive processes, and that's a major motivation for many of us here. When working with different data sets, you often need to repeat the same calculations over and over, and that's quite difficult to do, if not impossible, without programming. Visualization is also another thing that has come up a few times. Okay, so you seem to be in the right place, and along the during the course we will be collecting feedback from you, and that will help us to even tailor the course a bit more to your specific needs. But let's get back to our slides. So now I'm talking about the first part of the course, and there are basically 3 goals which are very nicely aligned with your expectations actually. So we will introduce you to Python programming language, already starting today in the second part of the lecture, and we develop basic programming skills, and we will discuss essential or good programming practices. So let's check the course's website already. Okay, so before I go through this, I will try to motivate you with some personal experience I've had with coding. So when I was studying, but one of the greatest things about this course, like I love teaching this course, I know David loves this course, and many students are very interested in this course, and I guess one of the things that makes this course special is that you're learning to program, and none of us are programmers. So I don't have any background in computer sciences or programming. David doesn't have any background in programming either, and most of you don't. So we know what we need. We know what you need. So you're working different disciplines. You're working in geology. You're working with GIS, geography, and very often you end up with this kind of data set. So that's what happened to me as well. So I have taken, when I was a student, I took courses like in C++ and C#. But when I was actually doing my PhD, that's when I noticed that, okay, I have a lot of like this kind of data sets, and I had to like repeat the same process, and my skills in programming was not enough, or I wasn't confident enough then. So that's the time that I really started programming, started learning programming more properly. So regardless of which field you're coming from, you probably have encountered CSV datasets or other format datasets that look like this. Of course, one easy way of looking at this data or analyzing this is just to take it to, I don't know, Excel or whatever spreadsheet program you use or other software. But you know that when you're working with programs, you have limitations. You're limited by what the software package is providing you. So if you're working with QGIS, for those of you who have done GIS, you know that there are some plugins that are available and there are some built-in functions. And if what you want to do is not available there, then you're in trouble because you cannot do that. You have to just do something else or improvise only because you didn't have the right tools. And that's quite annoying. Another major motivation for many of us is proper data visualization. Again, you might be in your own professions, you might be working with different software that allow you to make visualizations. It can be maps for geographers, or it can be different kinds of charts. And again, you know you're a bit limited like the software provides you a number of ways how you can modify the visualization, but you don't have unlimited possibilities. But with programming, of course, it depends on your level of confidence in programming, but basically you have no limitations when it comes to visualization. So during this course, we learn to move on from this data set, of course, not just visualizing, but also like reading the data, cleaning the data, analyzing the data, and then produce visualizations like this. We won't produce any maps in this period, but you will have the basic skills to produce something like this, and we will start producing those in the second period course if you take that one as well. Different examples of visualizations that you will be able to produce when you know enough Python. So this is a major motivation for students. Another motivation, as I briefly mentioned, is automation, and that's where the name of the course comes from, automating GIS-processes. Because programming for many of us is most useful when we have to repeat something. So imagine you want to perform a certain kind of calculation many times, or you want to produce the same kind of map for many districts around the country with the same parameters. So doing that manually will probably take days of your work, but if you write the code, then it's just efficient to repeat the thing. Okay, so hopefully we are already a bit motivated, if we were not already. And now we will get to some of the basic concepts of programming, computers. Yeah, so as I mentioned, a big part of this course is about starting to program, as it's the first time for many of you. And some of you, well, I guess not many because you have taken this course, but for some people, programming might be a bit scary, like at the beginning. But as you learn, you will see that it's not actually scary, and it's a very fun process, actually. Many students ask us, do we really need to know programming? And the answer is yes. You can do many things. Again, many of my examples come from GIS because that's my background. But you can be, for example, you can be a GIS expert if you only know how to use QGIS or ArcGIS. But if you really want to be a superstar who confidently says, I know GIS, then you don't want to probably be dependent on a software, a commercial software that may not be available to you in 10 years, or an open source software which may not be further developed in, we don't know, in 20 years. So if you want to be a superstar in your field, then programming is a very good addition. So geology and geography are becoming increasingly quantitative, and basic programming skills are one of the fundamental skills that help you be a better scientist. So sometimes you just want to move on, or for a certain project you don't want to use the software that you're used to at all. Again, if you're doing GIS, you may not want to use QGIS, you just want to do something in Python purely. But sometimes you want to just complement the software with the programming, and it actually came in some of your comments that many software come with the possibility to interact with the software through Python, or possibly other languages. So you can add the functionality of, for example, ArcGIS or ParaView or Google Earth or QGIS with a bit of coding. So you have the interface that you're familiar and comfortable with. Then you can just add a couple of lines of Python to, for example, automate a process. So a certain tool in QGIS would just run repetitively. So this is a screenshot from QGIS, and this is how you can, for example, open a Python console in QGIS, so you would benefit from the nice user interface that you are familiar with, and also you can add Python code there. So programming will not necessarily replace use of software, but it can very nicely complement it. In reality, actually, that's the case, because all of us still like to use the software from time to time. As I said already, programming can be very fun when you are like a bit more confident in what you're doing. So you're given a task, and the most exciting part of programming for many of us is the initial step. When you're given a task, and you have to break it down into pieces. So we will learn about programming concepts a bit later on, but you're calculating something, and you can break that something to an algorithm. So you take steps, you develop different functions, you will implement different mathematical formulas, and so on to solve the problem. And then you translate that to a programming, you translate it to a software, to a code, and then it's a process that just, it's like a bit like snowballing. So you start with a very simple version of your program, then you run it, you add functions to it, you make it better. Very often you will run into errors. You will see you have mistakes in the code. So it's a repetitive process, and it's a very creative process. So compared to, for example, running something just in a software, programming is very creative. So many of us actually enjoy doing that once we are a bit comfortable with writing the code. So all of this can be exciting and rewarding, and of course, that's when the code works. Sometimes it can be a bit frustrating. Those of you who have worked with programming, you remember those often read errors on the screen telling you that something is not working, and that can be frustrating, but you will learn how to approach those, and once you solve them, it is nice. And yeah. So the scientific method. So I would like, now I spend a couple of minutes telling you how programming can help you in excelling in scientific methods. So we are scientists. We want to use program to study topics related to our field of science. So these are the steps we take. There are different versions of this, of course. But generally, when you are, for example, working on your thesis, you define a question, so you want to answer something related to topic. So you come up with specific research questions. Then you gather information and resources. So you have to collect your data. You either collect your own data or just go somewhere download the data or get it from some organization. And then you usually have some hypothesis. So you have some ideas that this is probably the reason behind this. So then you want to use the data and analysis to test those hypotheses. And for testing the hypothesis, you have to analyze the data. Very often the raw data is usually not enough unless the topic is super simple, which is often not the case. And then eventually you want to publish your results. So it can be a thesis, it can be an exercise, or in your jobs it can be something you share with other colleagues or people. And then retest, or very often you have to do this over and over, especially if it is related to your job. So how does programming help you achieve those? It can help you gather information and resources. Along the course, we will see that it can fetch data, for example, through Python, and that allows you to interact with more services. It will allow you to perform different kinds of analysis and test the hypothesis you have. It will allow you to make visualizations, so it supports you in publishing your findings. Testing is a big part of programming, so it allows you to test your hypothesis and also to test the code you have written, and retesting, like maintaining something. Like when you have programming, it's easy to maintain or repeat the analysis you have. So if you have calculated something in a software, then you're done with it. Well, you might have saved the workspace, but still you have to redo it. But with programming, you can just run the same code for a different data set and you get the output. Okay, so before we start with programming has a meaning because we have computers. So let's see first if we know what we mean by computers, technically speaking. So let's open the Presemo again, and now you have a new question. I would like to see what you think of computers. So what is a computer? Okay, so let's go through some of your responses. Well, many of you think that a computer is essentially a machine which can store and process data, and that's quite close to the definition we provide in this course. So the core thing is the machine part, so you have hardware, and then you have data processing. So the question remains, where's the programming? And we are going to talk about that. It's a mega calculator, yeah. It's a tool for processing data. So you can think of it as a calculator, complex calculator, a machine that processes things or data, numbers in, numbers out. Yeah, that's how computers do things. A job for a person until about 1960. Yeah, the computers have replaced many old jobs, but of course they have also created new jobs for many of us. Some of you have listed the components of a computer, which are definitely part of computer, so different storage devices and processing components of the computer. Yeah, the RAM, and then 0 and 1, yeah, computers nowadays work in binary. Cannot understand emotion. Yeah, we will talk about the limitations of computers, fancy stuff. It depends on the computer. It can be fancy too. So many of us have already a very good understanding of what computers are. And as I said already a couple of times today, is that we are not computer scientists. So if you ask a computer scientist what is a computer, probably they will come up with a more fancy answer, what a computer is. But the way we understand computers and is enough for us is this. So we have devices, the input devices, we have CPUs, all those components that you mentioned already. And what matters to me is that I have input data, then I have a computer with all the parts, RAM, GPU, CPU, everything, that does the calculation for me, is the calculator part, and then I have the output. So what is the programming here? So a computer is a machine that stores and manipulates information under the control of a changeable program. And that's what we are going to work with. So you want to have control over how the data changes from input to output, and that's where we write the code. And that code controls the computer. So what are the things you already mentioned in some of your comments? The things that computers are good at. Computers are good at calculations. They're, as some of you mentioned, it's just a very big calculator, essentially. So computers are very good at well-defined, clear tasks. So you will see when you're working with programming, especially, that you have to be clear. Like if there is a doubt, if the computer doesn't understand what you mean, if the task is vague, it's not going to work. So it has to be clear. So that's why when I was saying programming is fun, is because you have a big task that can be a vague thing for the computer. You want to analyze, I don't know, density of something across a certain area. So that's a very vague task for a computer. But you have to break it down into simple tasks, like such as 2 plus 2, and then the computer understands it. So that's a big part of programming, breaking a vague task, complex task, into smaller, easy to understand pieces for computer. So we have well-defined tasks. Computers are very good at data storage and manipulation, and that has made our life easy over the past decades. Repetitive calculations, like for us humans, it's very boring and difficult to just repeat the same thing over and over. Yeah, you can do it 2 times, 3 times, but if you have to do it 100 times, most of us would give up. But computers don't get bored, so they're very good at repeating things and processing data or instructions, and that's what we do with computers and with our code. So something as simple as 2 plus 2 equals 4 is something the computer works very nicely with. But of course, they can do more complex things as long as they're clear. So we are going to look at this. This is just a simple Python code printing something. So you have a function that does something, you have inputs, and it returns a value to you. So it's very clear for a computer. So what are computers not good at? Some of you mentioned that they don't have emotions. That's very true. But also they're not good at abstract or poorly defined tasks, as I said. So if you ask the smartest programming language, what is calculate pi, without the pi number, the pi value, without providing instructions how to calculate pi, they're not going to perform. And if you're thinking of AI or LLM, those are different. These are not purely computer. They are programs already, and they are designed to handle all that uncertainty. So for example, this is the first 1,000 digits of pi, so you can never finish calculation with calculating pi, and that's a vague task. So for a computer not to crash, you have to say, okay, this is how you calculate pi, and stop after, for example, 1,000 digits. So tasks that computers are not good at. Computers, if you ask a computer, where are my car keys, they don't probably have an answer for you. But if you break it into understandable tasks, then they can maybe answer you, no matter how powerful they are. Like Lumi is the supercomputer we have in Finland. And we are going to actually work with CSC services during this course. And there are some tasks that just are impossible to solve, or they just require too much computing power. Of course, we have supercomputers, but sometimes with some tasks, even that may not be enough. So part of the art of programming is to simplify the task so the analysis doesn't last forever or take forever. So what is a program? As I said, you have input, you have the computer, all the fancy parts, and you have the output. The program is the changeable part that can control the behavior of the computer. So they used to be like punch cards at some point, I don't know, 60 years ago. Nowadays we have these nicer looking programming languages that we work with. So you write something, you get some output. So this is a piece of code that will create a chart for you, essentially. So a program is a detailed list of step-by-step instructions telling the computer exactly what to do. Like I said, computers are smart, but also they can be dumb. So you have to break your task into smaller steps and provide the instruction, and that's what we do with programming. The program can be changed or altered, so they're not fixed, and that's the nice thing. So they're modifiable. You can change it, and it changes the behavior of computer. Yeah. So program or software. This is the other name that is commonly used for referring to computer programs. So what is a programming language? So programming in its very core are those punch cards that you saw from 100 years ago. But what we have done over the time, we have developed these programming languages. So what you do, instead of putting binaries or numbers as inputs for your programming, we just have these fancy programming languages like Python. So you can just talk basically to the computer in a plain language, which is often English. And then that is translated to the instructions in a format that is understandable by computer. So that's the beauty of the modern programming languages. So two terms that you will hear about when doing programming is syntax and semantics. So programming languages are usually very similar in the logic and how they work, because they work with computers and there are some fundamental things they follow. So that's why they're similar. But what they're different in is the syntax. And syntax is the language, the wording. So for writing a print function or for writing a for loop, in Python you use certain commands. In Fortran or in C++, you might use a different wording. So the same concept of writing a for loop or some kind of loop exists in different programming languages. But the words you use for giving the command to computer is different. And that is syntax. The other thing is semantic. And semantic is what your code essentially means. So you write something and that means something to the computer. So the computer understands that meaning and performs the task you ask for. So what you should be careful when programming is that syntax errors are easy to fix. So for example, you have a typo very often. Like instead of writing print, P-R-I-N-T, you might misspell it or just forget to put N. Then you get a syntax error. So the computer is telling you that, okay, you have a typo or the syntax, the language is wrong. But what is a bit trickier is the semantic, the meaning. So you may not get a syntax error, so you have written the code correctly, but the meaning is wrong. So the way you're calculating the pi number is wrong. So that may not necessarily result in an error, but it might mess up with your calculations. And as I said, Python is just one of the many programming languages that exist nowadays. And it's quite popular for data scientists. So these are the steps. Broadly speaking, these are the steps when you take normally to develop a program. You come up with a list of instructions that you want to computer. As I said, you break it down into steps and you translate them into instructions for your computer. So you analyze. So the following list will serve as a general software development strategy. So you analyze the problem before starting to code, like how do I want to solve this? Then they determine the specifications. So for example, if you're working with inputs, what are the formats? Are you working with integers? Are you working with floating numbers? Are you working with lists, spreadsheets, CSV? What are the specifications? You create a design. Very often it's a good idea to just type in a pseudocode or just like overall idea of how the algorithm would work. Then you implement the design, and then you have to just go test it many times, because unless the code is super easy, very often you have some mistakes that you have to fix. And sometimes you need to maintain the program. Sometimes you just do the code for an exercise, you submit it, you're done with it. Sometimes it's for your job. You just need to keep it up to date. So in this course, you're going to see a lot of examples struggling with different temperature units, and that's the blame goes to David. So he's an American, and he's very used to working, well, he used to be used to working with Fahrenheit, and now he has been living in Finland for a while, and he has been struggling with understanding the temperature. So if you tell him it's 20 degrees Celsius, he has to like convert in his mind, is it, okay, how much is it in Fahrenheit? Is it cold or hot? So we have a lot of examples during this course with these conversions, and here's another one. So, yeah, so this is an example. You have a program, you have a temperature provided to you in Celsius or in Fahrenheit, and with a computer program, you can write a computer program that is going to tell you need to take a jacket with you in the morning or not. And what it does is that, okay, it converts Fahrenheit to Celsius or vice versa, and then you have this if conditions. If it is between 0 and 10, you need a light jacket. If it is 10 to 20, you don't. If it is minus, then you need a thicker jacket. So this is like how it is. So if you want a program that tells you whether it's hot or what kind of clothing you need, you can essentially do that. So the computer itself doesn't know what you should wear. But if you break it down into instructions, then you can do that. So you analyze the problem, like I said, and you determine the specifications. You create a design similar to what I said. Very often it's good to write a pseudocode or in your own language write the steps you want to take before you start using the syntax. And then you implement it, you write the code, and probably test it a few times until you have a bug-free code. And as I said, maintaining can be important if you're working in a company or if you're working with people. They may want to use your code. So like during my beginning of my PhD studies, I've written Python code that is in version 2 point something, and now we have Python 3 point something. So many things have changed. So that code would not run anymore without error. But if I maintain it, then people might be still used to use my code. So a bit of recap. What is a computer? It's essentially a machine that is good at manipulating the data. But how does the computer do that? It needs instructions for that. And that instruction is what we are going to learn this period. Giving instructions to the computer to be able to work with data and produce an output that you want. What is the program? As I said, the instruction. So the changeable part of the computer. Because you often don't change the hardware, or that's not the part you change for getting a different output usually. So the program is the soft part, or the software here. And we already talked about some of the steps you need to take in order to be able to develop a program. And this is a reference for some of the things we talked about. So it might be a good time to take a little break. So in the second part of the lecture today, after a short break, let's take a quick look at the website before we continue to the break. So this is the course's website. I already sent a link to you, geo-python.github.io. So this is the course's website. Depending on when you check the website, this part might have been published or not, so lesson 1. So we have some course information that you can check out, for example, where the classes are happening, and contact information of me and the assistants on the course, and the pieces of the course that we will talk about in the second part today. We already talked about the learning goals of the course, but if you want it in details for each of the weeks, you can find it under learning goals, under course information. About grading, you probably already know, but in this course we don't have a final examination, so we have a final project. So what we do is that we have weekly exercises starting already this week. So 60% of your grade comes from the weekly exercises. We have 6 of them, so each accounting for 10% of your overall grade. And at the end, you have a final project, which will make 40% of your grade. We are going to talk about this later today and next week, but just briefly, weekly exercises can be done in pairs or are preferably done in pairs, but if you strongly hate the idea of working with someone or you just cannot do that, just talk to us, we can work out something. But general idea is that we do it in pairs, but the final project is done individually. And the deadlines is always the next lecture. So the deadline for the exercise that you are given today is next Monday, essentially. About use of AI, and this is something that has challenged us a lot in recent years, especially with courses working with programming. My take on AI is that it's a good thing. It's like a calculator, but the question is that do you give the calculator to a second grader in elementary school when they're just learning to do mathematics? Probably not. So if you start using a calculator in elementary school, you probably never learn to do math. So it's the same thing applies here. If you're writing basic codes and if you don't do it yourself, of course, you're not going to learn it. So later on, like all of us, when we are doing more professional stuff, we get help from AI, and that's a very nice thing. But generally speaking, using AI for producing code is not okay, but since we want you to try out AI, there are some exercises in which we have specifically mentioned AI or LLM, large language model, okay. And in those parts, you can try out AI and see what you get as the output. We even have a lecture, I guess, on week 3 where we show you how to use AI and how it can be helpful or problematic when it comes to programming. So we are going to talk about AI. In general, it's a good thing, so I don't disagree with it. Just since many of you are new to programming, just use it wisely and don't produce the whole thing with AI, but unless it's been specified that it's okay to do so. And as I said, we will give you an introduction on this in coming weeks. Some information about licensing, like this is an open course, so other people can use it. And over the years, there have been many people working on this course, so what you see during this course is the result of work of many people who have worked as lecturers or assistants in this course. So each week we are publishing a new section called Lesson 1, for example, this week. Then we have Lesson 2 next week. We have the motivation for the, we have some information about the lecture. We have a lesson overview section every week, and this is where we write the overview of the course, the lecture that week, and also the learning goals. And this is where we publish the videos. So you can see the videos from the lecture of that week. Of course, I will record it during the lecture, and I will upload it only later that day or the next day. But this is where to find the lecture. And this first week, exceptionally, we have a slide. Normally, we don't have a slide, so you can find it here. Let's take that break now. I'm going to continue talking about the course environment and things we have to do. So let's be back here in 12 minutes, so 10:15. Continue. We have a lot of things to cover still, and we have like 1 hour and a half. One thing I forgot to mention is that I tend to talk a bit fast, mostly because, well, I'm like that, but also because we have a lot of contents to cover every week, but that doesn't mean that you cannot interrupt me. So if at any point you have questions or if something is unclear, then just raise your hands and we can discuss. Another thing I forgot to mention is about the grading. What we have done usually, and probably will do the same thing this year, unless otherwise specified later, is that for getting we have had very good students here, and that's why we have traditionally set the bar very high. For getting a grade 5, you need to have at least 95% of the overall grade. So that's a source of confusion for some students. So, because in many courses it's usually 90%. So 95% and more, you will get a grade 5. So we can start talking about the course environment. That's a very important part of lecture today, because you will be working with these pieces a lot during the next 6-7 weeks. So the course environment, we have Jupyter Lab for programming, and this is where almost all of our programming happens. So it takes a bit of time, a week or two, to get used to it, but once you get used to it, it's a very nice environment. Of course, you're more than welcome to set up your own Python environment. For those of you who have done programming before, probably that's familiar. You just set up the environment, Python, download the latest version of the Python, and install the libraries that we need, and you can do it along the way. But to make things easier for many of us here, we have a ready-to-use Python environment that is hosted on CSC. So those of you who are studying in Finland are familiar with CSC services. So it's a cloud computing environment. So we are running a Jupyter lab on CSC. So everything that you need for this course, all the libraries, all the Python installations, this has been done. But if you want to set it up locally, you're more than welcome to do that. We will be using Git and GitHub for delivering all the materials. So you will also submit your exercises and the final project through Git and GitHub. So we are not using Moodle or those services that you are used to from other courses, but we will have an introduction into Git and GitHub next week. For voting and polling, because the class is a bit big, to keep it a bit interactive, we have used these polls like we did already today. So that's the other environment we use. And then Discord. So previously we have used the Slack, but then something changed about the pricing and licensing. So a couple of years ago, we moved on to Discord. And I already shared the invitation link with you. And it's not on the website, because if it's there, everyone can join from all around the world. So you have gotten it through your email. So if you haven't already joined Discord, please do so. And if you know someone who has not received the email, for example, if they had not registered yet by Friday afternoon that I send the email, you can forward that email to them. But yeah, in Discord, we make the announcements. And also, you get support there. So for those of you who cannot make it to the help sessions on Thursdays and Fridays, me and the assistants are very often online during the working hours mainly. And if you have questions, we try to help you over there. So I can quickly show you, well, Jupyter Lab we start to work with soon. So what is Jupyter Lab? It's an open source web-based application for doing data science. The Jupyter Lab interface consists of different components, file browser, terminal, image. So it's a very nice thing. So instead of installing all the components of an environment you might need for your programming, we just run this. And you have everything you need. You have a terminal, you can create notebooks, and I will show you soon. We will start working with this already today. Yeah, so we will be using Jupyter Notebook. It is run on CSC, and I will show you how to run it. On each pages, on most pages where we have the code, you will see an option like this. It's a missile sign. So if you click on that, you can see also Binder. So it allows you to run like the code online. It takes a few minutes to load. But for those of you who are officially enrolled to the course, we use the cloud environment. So it's more efficient, and you can save things. This is like temporary. So this is more for like people who take the course from outside Finland, or if they're not enrolled to the course. So I will talk more about this before. So Binder is for those. It doesn't apply to students here, really. Yeah, so the CSC Noppe, you might see references of Notebook, and this is our mistake, because this used to be called Notebook until 2 years ago, so sometimes we still have the old name. But CSC Noppe, or formerly known as Notebook, is the CSC service that we will be using for hosting the Python environment here. And you will learn about it very soon. Yeah, I will go through this shortly. What else? Yeah, there are links here. So I'm on this course environment page. If you want to install Python locally, as I said, you don't have to. But if you want to, there are links here with instructions how to install Python. So that's also an option. Otherwise, we use CSC. GitHub, we will talk about it a lot from next week on. Yeah, about Discord. You have already gotten the link to Discord, and you might have already looked at it. Yeah, so most of our communication will happen on Discord. Okay, so now we're going to start working with Noppe. And this is how we do this. If you scroll down on this page, there is a section for CSC Noppe. And there is a link there. So this is something you have to, well, you have to go to NOPE every time you want to program if you are using the CSC service. But otherwise, this first step, you do it only once, joining to the, adding yourself to the workspace. So this is CSC NOPE. You have to log in. So if you already have a CSC account, you can just log in your CSC account using your CSC account. If not, we have this Haka login that students in Finland are familiar with. You can just log in with Haka, and you don't need to sign up or make an account. So I'm going to log in using my CSC account. Okay, so I have a number of things that you don't have. There are some templates available to you. So we are going to add GeoPython 2025. And for that, you need this code. So just copy this code. And in NOPE, there is a button up here, join a workspace. I'm not going to do that because I have the environment already. Just paste the code here, and it should add the GeoPython 2025 to your environment. So this is the same environment we will be using also for the second part of the course for those who are continuing. But okay, so did you manage to do this? Okay, great. So now you should have GeoPython 2025. Next thing you should do is to click on this power button, and it will open an instance for you. Depending on the server situation and how many people are doing this at the same time, it might take anything from 10 seconds to a few minutes. So now there are many of us doing it at the same time, so it might take a bit longer. Okay, so this is the environment you will be working with a lot during these few weeks. So this is our programming environment. This is Jupyter Lab hosted on CSC. So this is Jupyter Lab environment. There are many things available to you. So this is running on CSC, so on a Linux machine. Here, for example, if you're comfortable with Linux and command line, you can use the terminal. You have the Python consoles and everything. But what we will be working with a lot is a notebook. So a notebook is a Jupyter Lab specific file format. And we have put more information about it here. So you create files with this extension, IPYNB. So it's a Jupyter notebook. So most of the course's website is actually written in Jupyter Notebook. So what Jupyter Notebook actually does is a combination of text and executable code. So it's a very nice thing. You will see it a lot during this course. So important things here. We have two directories here. One is called My Work, one is shared. So you don't use shared much. We might use it later on during the course. So if I want to share some file with you, I will drop it there and you will all be able to access it. If you save anything here outside My Work folder here, every time you open a new session, everything will be wiped out. So if you have saved your work here, it will be gone next time. So if you want your files to stay, everything has to be stored in My Work folder. And this is persistent. So if you save anything in My Work, it will be there next time you load it, as long as you remember to save it before you quit. By default, Jupyter Lab has this auto-save documents on, so it saves your work as you progress, but if you turn it off, then you should just remember to save it with Ctrl-S or just file save. Just remember to save your file. Okay, so this is Jupyter Lab, and you will learn how to work with it very soon. Next thing we need to do is to get the lecture materials for this week, and this is something that we will be doing every week at the beginning of the session. So I try to find it here. Okay, so this is where the lecture materials are uploaded weekly. So it's a GitHub repository for those of you who are already familiar with GitHub. and this is the link to the GitHub repository. So what we do every week, we clone or we pull the latest changes from GitHub. So let's just copy this link, unless you want to type it in. And what I do now is I go inside the My Work folder. Remember, if I want this to stay next time I open a session, I have to be inside My Work folder. So then I'm going to clone the repository. So there is a plugin already installed for you called Git. So some of you might be more comfortable with terminal. You can just use the terminal as well. But this is a user interface, so it's easier. So Git plugin, clone a repository. So the next thing you do, you just paste the link you copied, this notebooks.git. You don't need to change anything else, just clone. Okay, so for me it was successfully cloned. So what it basically did is just downloaded the lecture materials from that public repository. So it's a public repository. It doesn't require you to log in or provide a username or password. From next week on, you will see that you will need your username, password, and we will create a GitHub account. But for now, this is public, so you don't need anything. So there are a bunch of files here. I open the directory L1. So every week we pull the changes, we update the folder, a new lesson will be added. And we have two notebook files. So this is what I told you about. These are the Jupyter notebook files. You see the extension .ipynb. So if you open one, the one called A Taste of Python. So this is the kind of file you will be working with a lot. So you have text blocks, which are the lecture materials and explanations about things we are doing. And then you have these code cells. So you can just type in the code, run it, get the output. So it's a very nice combination of text, images, and code in Python. So what you do with this is that you type in the code, and we're going to do that soon. But in order to run that cell, that piece of code, you press Shift-Enter. Probably something similar if you're using Mac. It's like Command-Enter or something like that. Okay, so this is something we will be doing every week to get our latest materials. So are we all here? Okay, good. That went smoothly. So now we want to already start programming. So basic elements of Python. In this section, we will introduce you some of the basic programming concepts in Python. So we will, for many of you, this will be the first time programming. So as we saw already on the slides, a computer is essentially a calculator. So one of the most basic things you can do with a programming language is to just calculate things. And that's how we are going to, this is how we are going to start things. So let's start by just writing some simple math. I'm going to go with 1 plus 1. And then remember to run the cell, Shift, Enter. So I just ran the cell. So this is my first line of coding today. It's very simple. It's not real programming, but we are running some code. So 1 plus 1 equals 2. So this is one of the nice things about Jupyter Lab environment. When you run a code and it has an output, the output will be automatically printed on the screen. So you got 2. But if you're doing this, for example, in some locally using other Python environments, you may not get the output right away, like readily. You have to print the output, and we will see how that works. But in Jupyter Lab, if there is an output, it is printed to the screen right away. So that was just adding 2 numbers. Let's also try different things. You can try different things. So I'm going to I want to multiply 5 times 7 and run this. So again, doing math using Python. So now you got a hang of like how you can run code in Jupyter Lab environment. You just write your code, Shift Enter, you get the output. Or if there is no output, then the code is just run. Well, of course, this is not what we are going to do with Python, just doing simple math. Well, we do math, but not as simple as this. We are going to use functions. So you can use Python for more advanced math by using a function usually. So you define a function yourself that carries out the task. For example, getting back to the example of converting temperature units from Fahrenheit to Celsius. So you write a function that does a certain task, runs some code, and you do the calculation. Very often there are functions that are coming with a library, with the Python packages, and then you just use those functions. So, as I said, in Python, in Jupyter Lab, you get the output. Without printing, but one of the functions that is very useful is the print function. You can see an example of here. So one thing we could have done was to just print this, and as I said here, the output would be the same because Jupyter Lab anyway prints the output to this screen. But you could have also done it this way. But we are going to revisit this later on. So we did simple math. We added two numbers. We multiplied two numbers. Now I'm curious to see if I can do something a bit more advanced. So I want to calculate the sinus of tree. So I will run this, and I get an error. So errors are going to be a big part of your programming. You will see them, and they help you fix issues. So they're your friends, not your enemy. So you get a name error. So what is basically telling you a name error is that Python is not recognizing the word sin here. So sinus doesn't mean anything to Python. And you might be surprised that, okay, I'm going to do very advanced stuff with Python. How come it doesn't know what sinus means? So let's try something else. So I'm going to get the square root of a number. I go with 4. You can use whatever number you want. So I want to see if I can get the square root of 4 just like that. And again, I get an error that Python does not recognize the word sqrt, short for a square root. So what is happening here is that some of the operations, like the most basic operations, like addition, subtraction, multiplying, division, these are built-in function, built-in Python functionality. So it is recognized by Python as it is. But anything else, like more advanced things, like for example sinus, is not a built-in mathematical operation recognized by Python. So for that, you need to access a library that does these things. So library is a thing that we will be using a lot with Python. In Python, usually it's called module, but I'm personally more used to calling them libraries. So Python comes with certain functionalities, the most basic things. It has also some libraries that come with the package. But if you want to do, for example, GIS is not a built-in ability of Python. You have to install GIS-related libraries to your Python. And we are going to see that a lot later on. But for now, for doing anything more advanced than just adding and subtracting, you need to access a library that is already coming with the Python package. It's called math. True math, so you don't need to install anything. So what you do, and this is a very important thing, you import the library in Python. So if you want to access a library, you use the keyword import. And in this case, the name of that library is math, and it comes with Python package, so I didn't need to install anything. So I will just run this, and here there is no output. So the code is run, the library is imported, and now it's accessible to me. But there was no output, so that's why I don't see anything, but it was run. So now I know that through the library called math, many of these mathematical operations are defined. So the sinus or a square root are defined. And if you are not sure, then all these libraries have documentation. You can just check how it's defined. So in order to access something from a library, and that something can be a function, it can be a value, you use dot. So math dot. And from math, I'm accessing the function sinus. And this time, again, I'm calculating the sinus of tree. And let's see if this works this time. It does. So now I get the output. So for Python, it's not difficult to calculate sinus of a number. It's just that you have to give it, like, you have to access it through the right library. So let's try the same thing with square root. And I'm going to get the square root of 4. You can try it with different numbers if you want. So now I can get the square root of the number 4. So is it all clear? So there are a lot of things you can do, you will see, in Python, and most of them come within a package or library or a module. What you do, you install them if needed. If it is already installed, then you just import it. And then once you import it, everything that comes within that package is available to you. In this case, we just access sinus and square root functions. So as I said, almost everything that comes within that package are now accessible to you. And that doesn't have to be a function necessarily, like sinus and a square root are function. You can also get constants, like values. For example, I know that in function, in a library math, the pi value is already available. So if you want to calculate, if you want to use pi for your calculations, you don't have to type it in. So up to a certain number of digits, I don't remember how many, it's already there. So if you need pi in your calculations, instead of typing 3.1415 and so on, you just put math.pi, value is there. So through libraries, you can also get values if they are defined there. Okay, so now let's take a minute and try something on our own. So use your Python skills to calculate the sinus of pi without typing in pi. So just write that one line of code and calculate the sinus of pi. So you can type your code here. Remember that in Python, if there is this hashtag sign, those lines are not executed. So it's for writing comments. So this line, I can write whatever I want after this sign. And this is not going to crash anything. It's just for writing comments. So just ignore. You can delete those or just go to a new line and type your code. So let's just calculate the sinus of pi. How many of you managed to get the output already? Yeah, about half. Okay, so I start doing it at the same time. Like I said, these lines are ignored. So this is something that we will use a lot, and it's recommended to comment your code, because if you write a piece of code now and you revisit it in 2 months, you may not remember why you have written a certain thing. So it's good to comment and say, okay, for example, here I say, here I calculate the sine of pi. So next time when I look at my code, I remember, okay, that's what I'm doing here. Because this is simple, but imagine it can become more complex later on. So from math, I'm accessing the function sinus. And I'm not going to type in pi. Like I said, it is also accessible from math. So what is happening here? Python is first fetching the pi value from library math, and then this library is fed into math.sinus. So it can be nested. You can just import different things like this from the same library or different libraries. So let's just run this, and we get the output. So it's a very small value. So we already saw how we can combine functions. Well, this is not a function, but same logic applies to functions as well. I already briefly showed you the function print. So print has nothing to do with a printer or printing like that. So in many programming languages, printing is just showing the value to the screen. And that value can be anything. So it can be just a piece of text. So I can just say hello. And if I run it, it just prints it to the screen. So like I said, if you do it outside Jupyter Lab, you have to add this to print your results to the screen. But here I'm going to show you something. So you can use nested functions. So you can use a function within a function. So print is already a function. Inside it, I can use math.square root. So what this does is that first this one is run. So it calculates the square root of 4, which is 2. And then it prints it. So you get the output, which is 2. We are going to use many different functions later on, but so it will start to make more sense later on. When using print function, which is a very useful and highly used function, you can also combine text with your values. So imagine you are writing this code for some user, like someone else, and you want the output to be informative, not just a number. So you can add a piece of text. So this is how I do it. I use a print function, and then I add a text. So remember that in many programming languages, like almost all that I know of, that if you put some text or whatever between these quotation marks, it is regarded as text or a string. So now I'm going to run, and so it doesn't look at the contents. You don't get an error, because otherwise you will get an error because it doesn't understand you. But now I'm just saying this is a text. You don't have to understand it. Just print it. So I'm going to write the square root of 4 is, so the square of 4 is, so this is just a piece of text. You can write whatever you want. And then following this message, I want to print out the actual value that I am calculating. So I get math.sqrt of 4. And remember to close all the parentheses. It's something you have seen in other programming languages and also, for example, Excel. So every bracket you're opening, you have to close it. So let's just run this. So you see, I have a message printed out. The square root of 4 is, then 2. So you can combine text with values when you're printing. Is it all clear so far? Okay, great. So very often, and again, these are things that we are going to use over and over. So if you don't see the purpose of it right away, it's okay. You're going to use it later in real context, and it will make more sense. But variables are very important concepts in programming. Variable can be used to store values calculated in expressions and used for other calculations. So very often you want to use the same value over and over. So you get the square root of 4, but you need this square root of 4 or whatever number many times in your code. So it doesn't make sense to type it every time, like math.sqrt4. What if I just calculate it once, store it in a variable, and give it a name, then I can just reuse that. So this is something that we do all the time in programming, especially when calculations start to get more complex. So now I'm going to define a variable. So what you do with variables, you give them a name. So I'm going to call it temperature Celsius or temp_Celsius for short. So I don't have to type too much. And I'm going to give it a value 10. So I'm going to work with this number. So this is how variables work. In many programming languages, especially like a bit older languages, you have to specify what are the inputs. What is the format of the number? Is it an integer? Is it text? Is it float? Do you have decimals? But in Python, it's like automatically recognized. So you don't have to explicitly say this is a float. It already knows that it's a number, it has decimals, so it's a float. So that's a nice thing about Python. So let's just run this. So you don't get anything as output because we don't have an output, just temp Celsius is defined. So Python knows that you have a value is 10 stored under temp Celsius. As I said in Jupyter Lab, if you just put the name, it's going to give you the output if you run them. But if you were using this somewhere else, you had to use print. So you could have also just put it in the function print, and it prints the value for you. So that's not surprising. We defined the variable with the value 10, and we are getting the output. So now I'm going to do something a bit more advanced, and I'm going to we are going to print the value of temperature Celsius in degrees Fahrenheit, and we know the formula for this, so you can just Google if you already don't know, to see how you can convert Celsius to Fahrenheit. So we do that by multiplying temperature Celsius by 9 divided by 5 and adding 32. So that's how we do it. So now I'm going to do this conversion and print the output. So I want to add a piece of text at the beginning so it makes more sense for my reader. So I want to say temperature in Fahrenheit. So then I'm going to calculate it. So as I said, the formula is this 9 divided by 5 multiplied by temp Celsius. So instead of typing 10, I've already defined the variable. So I just use the name of the variable. Then what you do next is you add 32. And make sure to close the bracket. So as you can see, I have a typo here with print. I forgot I, and it's giving me a name error. It's just telling me that, okay, I don't know what PRNT means. So I'm going to fix my typo. Run this again. So you see the output is 50 degrees Fahrenheit. So 10 degrees Celsius is 50 in Fahrenheit. So now you did a bit more advanced calculation, and you printed the output with a custom text. Now we are going to take a minute and try something on our own. I want you to define a variable and display its value on the screen. The variable value can be anything that you like. Yeah, so try this now so we get a good hang of working with variables. Just define a variable, store a value in it. We are going to talk a bit later today about variable naming. So just remember that, for example, I'm going to tell you more about this, but you cannot, for example, name a variable with a space in between. So this couldn't have been temp Celsius like this. You get an error. So you had to have something in between, like underscore. And we are going to talk about this, but to make things readable, if it's temp Celsius, then very often people use underscore between, so temp Celsius. Or some people prefer to use this pothole case naming, I guess. Or yeah, so you just use capital to divide them. But we are going to talk about this. Doesn't matter how you do it, just don't get an error. And remember, the variable value doesn't have to be number. It can be a text. So, did you do it already? Yeah, so I will try it. I just name a variable, my underscore variable. You might be more creative with your naming. And I'm going to store a value in it. So I'm going to use string. So I'm just saying Python is cool. So this is the value that is stored. I want to also get it to the screen, so I will just put the name there. So Jupyter Lab will print output for me. So my variable. So this is the output. So I defined the variable and I printed it here. So of course I could have just printed it more explicitly if I was outside Jupyter Lab, like this. So the great thing about defining variables is that you can reuse them. So if later in my code I want to print the same value or do some calculation based on it, I can just call the name without typing in all the values or recalculating things. So updating variables. Very often you need to update the variable. So now you define temperature Celsius as 10. What if you want to change it to 15? So it's very easy. You don't have to do anything. Just redo the whole thing with a new value. And it will replace the former one. So I will redefine temp Celsius. And this time I give it a value of 17. And this should update it. So let's just run this. And if you don't believe me that this is already updated, you can print the value. So I'm going to print the value with a bit of text, temperature. In Celsius is now here. I put the value to see what I have stored in this variable now. So you can see it used to be 10, now it's 17. So if you just assign a new value, it will overwrite whatever you had in it. So you have to, it's a good thing, it's flexible, but also you have to be careful because it can overwrite what you had there already. So one thing is that you already saw the name error type error. That is just telling you Python does not recognize a word. So if you try to access a variable that you have not defined yet, for example, now we have temp Celsius, but I haven't defined temp Fahrenheit. So if I try to access something that I haven't defined yet, I will get a name error. So print temperature in Celsius. So I'm going to recalculate the value from Fahrenheit. So this is something that is wrong, but I'm trying to do it now. So temp Fahrenheit, we haven't defined it yet, so probably, well, it will result in an error, but I'm just going to show it to you. So if you run this piece of code, you will get an error that temp Fahrenheit is not defined. So if you want to use a variable, of course, you have to define it first. So what I'm going to do now is to define temp Fahrenheit. So I'm just repeating that formula. Temp underscore Celsius. Plus 32. So now I calculated something, and the value, whatever it is, it's going to be stored in temp Fahrenheit. So I can access this later without typing everything all over again. So now I make a new code using this variable. So I put a bit of text. Temperature in Celsius. Then I put the temp Celsius that I had already stored in a variable. So you can add multiple texts, multiple numbers when printing. And in Fahrenheit, I don't type the whole thing, but you can type it if you want. Then here I just put the variable I created, so temp Fahrenheit. So this should now work unless we have a typo somewhere. So it works. So temperature in Celsius is 17 and in Fahrenheit is 62.6. So now we didn't get a name error because we had defined both these variables. So remember that if you have a variable called temperature Celsius, and based on that variable you calculate the temperature in Fahrenheit, if you update the temperature in Celsius, it will not automatically update the Fahrenheit, because you have already calculated it and it's stored in that variable. So just be careful with that. If you want to recalculate the Fahrenheit based on for this new temperature in Celsius, then you have to just rerun the code. So let's test this. So I define a variable called temp Celsius. And I give it a value 20. You can try it with different values. Then I'm going to print something. So I add a bit of text. So I'm already lazy to type, so I make it a bit shorter, but you can type the full thing. So temperature in Celsius is now . And in Fahrenheit is still . Yeah, so the value is not updated. Well, it's an obvious thing. If you update the input, unless you recalculate the output, it's the same. So be careful with that. So data types, I already briefly mentioned that in many programming languages, you have to explicitly, like in C languages, you have to explicitly define the data type. In Python, it's a bit smarter. So the data types that we'll be working with are integers, so integers, values without decimals. Then we have float. You have decimal values. You have a string, or short for the short name for it is str in Python. So it's character string. It can be anything. It's between quotation marks. And we have Boolean values, which are binary, true or false. So we are going to work with Boolean values when we work with, for example, if statements, the conditional statements. But these are the data types that we work with. Something that we will be doing a lot during the course is to test what is the type of the data that we are working with. So let's test that already now. So I'm going to create a new variable and call it weather forecast. And the weather forecast is as simple as this. It's going to be a hot day. So there's a built-in function in Python that gives you the type of the data. So now it's obvious, it's a string, but imagine later you are going to work with more advanced data types. So type, and I just copy and paste the name of this, or you can just type it in again. So I'm testing the type of the data that is stored in this variable. So if I write it, gives me str. So it's telling me the values is string. It's a text, so it makes sense. So if I had a number there with decimals, it would have told me that it's a float. Or if it was an integer, I would have got an int as the output. Okay, so now I'm going to test another thing. Remember, we had defined this other variable called temp Fahrenheit. So I'm going to test the type of the data is stored in it, temp Fahrenheit. So you can see it's a float. We had decimals in the value, it's a float. So what if I combine two values of different type? So I'm going to add another line of code here. So I name the output as temp Fahrenheit. And what I'm going to do is to add temp Fahrenheit to weather forecast. So remember, weather forecast is a string, and temp Fahrenheit is a float. So let's see if we just add them up together. So you get another type of error, type error. So it's just telling you that you cannot add a float to a string. Remember, when we were going through the slides earlier, you have to be clear with the computer. So with the computer, you're saying add hot to 5. So what does that mean? It doesn't mean anything. So that's why you get type error. But as it turns out, it's possible to do some math with character strings in Python. So let's try one thing now and spend a minute on it. Define two variables and assign them character string values. What happens if you try to add two character strings together? So create two values, weather, hot. And what happens if you put weather plus hot? Will you get an error if both of them are string? Try also subtracting them. And try a bit other, like try to multiply. Try a few things to see what would work and what wouldn't. I will also do it at the same time, but you can do it your own way. So I create one variable and I will name it first variable. And I make a string. I just use Python as the value. I create a second variable and I'm naming it conveniently second variable. And the value is cool. So now I'm going to try a few things and print the output. So I want to see, now that I have a string in both of them, what happens if I add them up. So first variable plus second variable. I want to also test another thing. I want to see what happens if I multiply 5 by the value I have in first variable. And while we are here still, let's try one more thing. And I'm going to see what happens if I put first variable minus second variable. So you could do this in different cells, but I'm just doing it all in one place to see what's the output. Yep, so it works for all of them. Let's go one by one. So if you just add them up, it works. So this had a value called Python. If I add it to isCool, it's just going to put the strings together. So now I'm going to try it with 5 times. So what happens is that if you put 5 times a string, it just repeats that string 5 times. So now you have Python printed 5 times in a row. So the thing that caused error was this last one. So when you were subtracting them, it didn't work. So if you say minus, like Python minus isCool, then Python is confused. Your computer is confused, like what should I do? So plus, they have they have predicted that, so something happens if you add them up. It just puts the strings together. With multiplication, it happens, you get something. But with minus, it didn't work. So sometimes it works. It doesn't mean that if you have different type data, nothing works between them, but it has to make sense by the computer. Sometimes you can also change the data types, so you make them work together. Okay, so let's create a new variable called forecast. Forecast high str. So it's a string. So it's a temperature. For some reason, it has been defined within a quotation mark, like this. So it happens sometimes if you have loaded your data, you probably have seen it before. Like it's a number, but Excel or whatever software you're using is recognizing that it's integer because, for example, it's within a quotation mark. So this is a number, but because it's in quotation mark, Python is going to think it's not a number. It's just a string. And you can see when you print the value, it appears like this. So it's just telling you that it's a string, not a number. So if you do math on this, it's not going to work because it doesn't recognize it as a number. You can also test the data type. So let's see the type. And you can see it's a string. So even if it's a number, because it's in quotation mark, it's not recognized as a number. But in this case, you can easily convert the type. So I'm going to create a new variable called, so one thing is that you can add new cells because there are no more cells here. I'm adding new cells to write code. You can also delete and move things around. So in Jupyter Lab, you can do that. So I just created a new cell to write more code. So I'm going to create a new variable and call it forecast high. And this is how you do the conversion. So I want to convert a string to a float. So I just write float, the name of the data type that I want. And the input is, of course, the input variable. So I want to convert forecast high string to a float and store the output here. So let's just run this. So now it's done. I just put the value here to get the output. So now you see it's a number. It's not in the quotation mark anymore. So if you want to convert a value from string to float, as long as it makes sense, like you put float and then you put the value, the conversion is done. Then you can do math, so you don't get an error. Because otherwise, if it was recognized as a string and then you do some mathematical operation on it, you get an error. So you can do the same thing on with the different variables. So let's do a bit of math here. So I have this new variable called forecast high. I've subtracted from temp Fahrenheit that we had worked with before. And now it works because they're both numbers. So if you remember, what we defined as temp Fahrenheit earlier had decimals, so it was a float. So let's see the value. So it was temp . So 62.6. So I can also convert this to an integer. So remember, integer by definition doesn't have decimals. So I can create a new variable called temp Fahrenheit int. And the value for it is the integer of what I already had stored in temperature Fahrenheit. Now if I check the type for this new value, you can see it became an integer. And if you look at the value, you just lost the decimal. So it was 62.6. I converted it to an integer. Because integer cannot have decimal, just Python got rid of the decimal. So you lost the the 6.6. So if you want to round numbers, this is not the best way. So it doesn't round it to the closest number. It just drops the decimal. So even if it's 62.999, if you make it integer, it becomes 62. It drops the decimal. So there is a separate function that we will be working with later on called round, and that rounds the number more correctly, like, for example, to the closest integer. Yeah, so these conversions work as long as it makes sense. So for example, if you have a text, you want to convert it to a float, like weather is hot, that's the value. If you want to make it a float, then it doesn't make sense. Python doesn't know what to do with that. What is weather in hot in float? So as long as it makes, you can do such conversions. Yeah, so that was the first time doing a bit of coding. These are just the basics. We are going to cover the basics the first couple of weeks, and then things get more interesting. But is it all clear so far? Okay, so this was the programming part, but I still would like to show you something. And that's good coding practice. We talked about variables and naming them already, but we didn't cover the details, and now I'm going to tell you a bit more. So we didn't think too much about making the variable names, but there are a few rules governing what names you can assign to a variable. One of the first keys is that, okay, you cannot have a space in between, as I said before. So if you want to name temp Celsius, you cannot put temp space Celsius. You're going to get an error. So you divide it in different ways. Another thing is that it cannot be a keyword in Python. So there are words in Python that do something. For example, the word import, you already saw. If you want to see a list of things that are like reserved keywords in Python, you can just import keyword and print the list like this. So these are the words that you cannot use in Python to name something. So you cannot have a variable named false, because false means something in Python. Or you cannot name something global. You cannot name something int, float, or lambda, or these are words that do something in Python. So that's one thing. The other thing is that your variable name cannot be a number and cannot start with a number. So you can name it temp1, but you cannot call it 1temp, like as a number. So these are things that you should avoid, otherwise you get an error. There are also some rules that, not rules, but like good coding practices, some practices that help you name your variables more properly. When you're naming, it's very tempting to go for a very short name because it's less to type. But remember that later on, already during this course, you're going to make programs that are longer. It can be like, I don't know, tens of lines of code. So if you have just named something S like this, it makes sense when you name it. But if you're looking at it after 2 weeks, you don't remember what it was. So it is recommended when you're naming a variable, go with a name that has a bit of information. So if it is overly short like S, it's not good. Or even SID, it's just short. What is S? Also, this is accepted by Python. It can be as long as this. But it's not a good idea because, well, it's hard to read, hard to type, and everyone who uses your code will hate you for that. So do not do that. So what is usually done is that you make the name short in a reasonable way. And we are going to look at some examples of how to do this. Another recommendation here is to avoid other languages. Of course, you can use whatever language you want. Well, one of the things is the coding. So if you're using, for example, Finnish, and you have those letters that they don't exist in English, you might get an error. Sometimes your Python environment will just handle it, sometimes it doesn't. So it's just safer to avoid those letters that don't exist in English. And because the general rule in world of programming is that, well, the language is English in programming, generally speaking. And you want to write your code so that other people can use it. So the good practice here is to try to use English words to name your variable. So if you end up sharing your code with someone else, they can more easily understand what you mean. So avoid names that are overly long, avoid names that are super short and don't tell anything, they're not like intuitive, and avoid names that are in other languages. Yeah, so these are a few good practices when it comes to formatting variable names. So this is called pothole case naming. So you have different words, FMI, station, ID. So if I was lazy, I could have named this FSID, and probably no one would have known what I mean by FSID. But this is a good name, FMI station ID. And I've separated the words with underscore. So remember, I cannot put minus there, because minus there to Python means minus. It's a mathematical thing. It gets confused. But underscore is fine. So this is one way of naming variables properly, and try to get used to it. So if you have multiple words that make sense, and you're separating them by underscore. Another way is this camel case naming. So FMI station ID. You don't put underscore, so it gets a bit more concise, but you separate the words using a capital letter after when a new word is starting. So this is also a good coding practice. So if you do this and someone is reading your code, they know that, okay, you're a good programmer. You know how to write decent code. Yeah, so that was a bit about good coding practice. Every week we have something like this. So it's not essential. If you have a bad name for your variable, you're not going to get error. It's just not good coding. Now we have still a bit of time. I will show you what we will do in the first week exercise. Do you have any questions from this part? If not, I will show you what we will be doing this week. So our exercise this week, so everything, as I said, is published on the course's website. So there's an exercise 1 section, and the deadline for it is next week, 8th of September, 9:15. So these are your tasks for this week. If you do not have a GitHub account already, please create a GitHub account this week by next Monday. It's a free account. You don't have to pay for anything. They have all these pro versions and everything. Even I don't have those, so you don't have to pay for it. So just sign up for GitHub. That's the first thing you do. The second thing you do is to share, well, I assume you have already joined Discord, or you're going to do it very soon. And once you have created your GitHub account, you're going to share your GitHub username with us via Discord. And why is that important? Because on GitHub you have a username, and there are people taking the course from other parts of the world just trying. So through your GitHub name, we know who to grade and assign grades to. So that's important information for us. And you already do some Python coding, and I will show you a bit briefly how it works. So there are instructions how to create a GitHub account, but it's the same as creating any account on any website. So you just go to github.com and sign up. You provide your email. It can be your university email or personal. It's up to you. And many of you who have done programming probably have a GitHub account already, and you can use that for this course. Yeah, so that's the first part of your exercise. Easy. Second part is joining Discord if you haven't done so yet. So what you do on Discord, you go to week 1. I showed you that we have divided the Discord to weeks. On week 1, each of you should go to the channel and write your name, your GitHub username, the code of the course you have taken. So are you the geography version or the geology version? And the name of your partner. So as I said, we are going to do this in pairs. So everyone will have a pair. And we are going to talk about this more next week. Now, the first week we do things individually. So the idea is that every week you do the work together, but one of you will only submit the exercise. So each week we have a driver. So the driver is the person who submits the exercise. So you will have pairs. So if you already know who you are going to work with, just use this format and tell us who your partner is. So all of you have to do it. So even if your partner should also provide this information as well. But if you cannot find anyone to work with, you can just put a question mark in this part. So instead of telling the name of your partner, just put a question mark and we will find you a person you can work with. And if you have some strong reason why you cannot work with people, you don't live in Helsinki, or for whatever reason it's hard to communicate with the partner, just let us know. The person, the assistant who is in charge of taking care of groups is Emilia Oinas. So she will be responding to you, and get in touch with her if you have some strong preference on doing things differently. For those of you who are coming from other universities, also tell us which university are you from. So we have Turku, we have also probably other universities as well. And then the next part of your exercise is to write a bit of Python code. So it's very simple, very similar to what we have done today. But there is one thing. So as I said, we use GitHub Classroom for doing our exercises. So each week, and now we haven't learned GitHub yet, we are going to learn it next week. So it's might be a bit confusing now. But every week you have a link like this for accepting the GitHub Classroom assignment. So if you just open this in a new tab, and this is something we will do every week. So it's asking you whether you want to accept to join this exercise, and you accept. So this is my GitHub username. When I do this, it creates me a repository for that exercise, and it's private. Only us teachers can see it. Other students cannot see your work. So if you open this I open it in a new tab. So this is what was created for me. It's a space. It's a repository where I can do my exercise. We are going to learn about GitHub later, so now we don't really need it. This is only what we need. We only need this for returning your exercise. So once you do this, you get a link. This is your repository. Once you do your exercise, just come here and add the file. So upload the file here. Later on, we will do it like through programming. So we will create the file, we will push it to repository. And those of you who already know how to do this, feel free to just push the changes to repository. But because we haven't learned Git yet, just accept the assignment, go here, and just upload your file. That's it. It's like uploading to Google Drive. It's not different. It just looks different. So, but we will go through details of GitHub next week. So what we do, there are instructions here. You create a new notebook, and this is how you create a notebook. So you just go to your work folder somewhere. Here you can create a new directory like this, like exercise 1. And inside this folder, you can create yourself from launcher. You can create a blank notebook. Like this. So you do your assignment, you have to do some coding, you do it, and then you save it. You give it a name that you want. So this is you do your assignment, you do the changes, you save the file, and then you can download this. So you just right-click, you download it to your computer, then you upload it to GitHub. And later on, I will teach you next week how to just push it from here. So you don't have to take these steps from next week on. Just this week. So does it make sense? And there are detailed instructions on the website, so you will see. And we are there to help you on Thursday and Friday, and on Discord. So if you run into problems, we are there to help you. Okay, we are early, but that's okay. If you don't have questions, we can wrap it up here, so we can go to lunch before the queue starts. Yeah. Have a good week, and see you next Monday.